So this is going to be the intro to linear equations. In our last chapter, we went over isolating variables, creating equations, and we already know what an equation looks like. For starters, can an equation look like this? Marcus? No. Why can an equation not look like that? Who can tell me? Why not, Tyson? That's because this is the answer. Exactly. That would just make it x equals 8. We just solved it. That is the answer. That is not an equation. However, it did have something right. All equations need to have something in it. We know all equations need to have what in it? What do all equations, Sean? Equations. A question, not a question. What is it, Marcus?
A variable.
That's good. They do need a variable, but what is the one I'm looking for? Equations. Equations, yes. Equal sign. Thank you, Bridget. So all equations need an equal sign, but they also need this. When we're doing it, we have to have a variable, some kind of operation, and a number is going to be equal to a number. However, there is one exception where we can set it equal to a variable, and we're about to see that one exception here. So, when dealing with linear equations, we're now going to be dealing with two variables. So, normally we're used to just seeing one variable. We're used to seeing, for example, x plus 3 equals 7. When we show our work, we do minus 3 equals minus 3 because we want to isolate that x. We want to get it all by itself. Plus 3 minus 3, that cancels out. We would get x equals, and 7 minus 3 is 4. But now that we're grown-ups, what we're going to be doing is there's two variable equations. We're going to have ones that have both an x and a y. Now, it's no need to worry because they will tell us what the value of one of the variables means. So we still have to find the unknown, but what you're going to be given is you're going to be given a function table. Sometimes it'll be a t-chart, and sometimes it'll be a graph. And it'll tell you what the value is. But let's start. Let's just look at an example. So if we look at our first example, we have 3x minus 2y equals negative 16. The first thing we want to do is we want to write it in slope intercept form. Now, who can tell me what slope intercept form is? Who can tell me what slope intercept form is? See, Sean? Perfect. Y equals mx plus b. So y equals mx plus b. Now, what do each part of those stand for? So what does one part of that stand for, Victoria? What does one part of that stand for? What does the m stand for? It stands for our slope. Thank you. Other Victoria, what does the b stand for? You want to call on a lifeline? It is the Y-Intercept. Excellent. And I'm going to go over more of what these terms mean. We're going to label our graph. What is this point here called? The one right in the center of our graph. Who remembers what that's called, Joey? Yes, it is the origin. And that's because where everything originates. Now, what is our horizontal axis? What is the axis that looks like that called? Our horizontal axis, yes. It is not the y, so it is the, Kyle? X. So, as such, the vertical axis is our y. When we're doing an ordered pair, what comes first, x or y, Tyson? X. So it goes x, comma, y. I'm going to show you a line. So here is my line that I have so nicely made. It continues on. I just didn't want to continue drawing it because I was already very impressed that I drew it correctly. Now, we're talking about something. In the other thing, we heard the word slope. What does that remind you of? What does this line here remind you of? Can you guys think of anything that you know with the slope that it reminds you of? What is it? Yes. So Joey points out a downward slope, like when you're skating. Exactly. So the slope is how tilted something is. It could be a downward slope, an upward slope. It could have no slope at all. So we have to figure out what the slope of the line is. And then we have to figure out the y-intercept. Where do you think the y-intercept would be on this graph? On this line, where do we think the y-intercept would be? So Tyson and Asante got it. It's right here. And that's because that is where the line is intercepting the y-axis. And notice that's when x is 0. Because our x value is 0 and our y value is something. In this case, it's like 1.5. It's not really the point. So that would be our y-intercept. Wherever the line is touching the y-axis, whenever the line crosses that y-axis, that is our y-intercept. So the slope is how tilted something is, and the y-axis, or the y-intercept, is where it touches that. So here's where we have this, the y-intercept. We have our y equals mx plus b. Let's look back at this problem. We want it to look like that. We want it to look like y equals something x plus something. Now, can that plus be a minus? What do we think? Can that plus be a minus? What do you think, Bridget? Yeah, it can. The plus is just there as a placeholder. It can be a positive or negative. For example, it's the same as plus negative 3. That's the same as just minus 3, right? Yeah. Can it be times? Can it be multiply? No. Can it be divide? No. Remember that we learned before addition and subtraction are the same thing, that they're just opposites of each other. They're the same thing. Multiplication and division, same thing. They're just opposites of each other. So it can be either a plus or a minus, but it cannot be anything else. So we want to isolate the y. When we do this, we have to do reverse PEMDAS. So PEMDAS. We have to go this way because we're working away from getting our answer originally. So we have to do subtraction or addition first. We want to get that y by itself. So what's on the side of the y that we have to get rid of? What are the things on the side, Sean? So we have a negative 2 that we need to get rid of. And what else do we need to get rid of that's also on the side of the y? Marcus.
The negative 16.
That's not on the side of the y. The negative 16 is not. Tyson? The 3x. So both of those are on the side of the y that we need to get rid of. Now, that 2y, that negative 2y, what is happening? Negative 2y means negative 2 what y? What operation is happening? Kyle. Not subtraction. What operation is happening? Joey. Multiplication. Because when a number touches a variable, it means multiply. So we have to do reverse PEMDAS. Can I get rid of that negative 2 right away? No, because it's multiplication. So I have to get rid of that 3x. How do I get rid of that 3x? What am I going to do? Let's look at this other one. When I had 3 plus x equals 7. To get rid of the 3, I did a minus 3 on each side, right? That went away, and I got x equals 4. So how do I get rid of that 3x? What am I going to do? Let's take a guess. What am I going to do, Joey? We're going to isolate the variable. We're isolating the y, but how? What am I going to do to get rid of that 3x? Does anybody know? What am I going to do, Joey? I'm going to subtract 3x. I'm going to subtract 3x from each side. So let's watch. What's 3x minus 3x? What is 3x minus 3x, Vito? 0. It goes away. I'm left with negative 2y equals. What's negative 16 minus 3x? Think about this a little bit, Sean.
13?
It is not 13. Remember the rule that we have. It has to do with combining something. Combining what kind of terms? What is it, Joey? Combining like terms. Negative 16 and negative 3x. Are those like terms? No, because one has a variable and one doesn't. So we are simply left with minus 3x minus 16, right? Looks good so far, doesn't it? Now what do we have to get rid of? Now we are left with one more thing that we have to get rid of. That other thing we pointed out earlier. We have to get rid of this negative 2. So that's negative 2 times y. How am I going to get rid of it? If it's negative 2 times y, how am I just going to get us down to a y equals? If that's negative 2 times y, how am I going to do it? Asante. I can't subtract when they're being multiplied, so how do I do it, Tyson? I'm going to divide. So I'm going to divide. What am I going to divide by? Exactly. I'm dividing by negative 2. You always have to remember that it includes that operation. So I'm dividing each side by negative 2. Negative 2 divided by negative 2 becomes 1. We are left with y. But we have to do this whole side divided by negative 2. So we're going to do it to each part. First of all, what is negative 16 divided by negative 2? Negative 16 divided by negative 2. Sean?
Negative 8?
He says negative 8. What do you think, Joey?
Is it just 8?
Just 8? It is just 8. Because the negative and the negative make a positive. Exactly. A negative times a negative is a positive. Same with a negative divided by a negative is a positive. But we have to do it to this other one too. Negative 3x divided by 2. Is 3 divisible by 2? No. But we could just do that. We make it look like that. Remember? Negative 3 divided by negative 2x, right? So, negative over a negative. What does that become? Positive. So those go away. So we are going to be left with 3/2 x plus 8. You could also write this as, I'm going to clear this whole thing. We had y equals 3/2 x plus 8. You could also write it as y equals 1 1/2 x plus 8. Some teachers prefer you to write it in this way. I tend to like to keep my numbers as improper fractions. Because whenever you have to deal with them, you have to make them back into improper fractions and then back into mixed numbers. So I just like to keep mine as improper fractions. So let's look at a second one together. We're going to look at this problem. It looks like this. 13x minus 11y equals negative 12. Now, what is our end goal? What do we want it to look like? We want it to look like a something equals. What do we want it to get down to? Sean?
Y.
Yes. We want it to look like a y equals. You're going to hear that a lot. You want to get it down to a y equals. So the things on the y side we have to get rid of are 13x and that negative 11. The negative 11 is being multiplied and that 13 is just being added. How do I get rid of that 13x? How do I get rid of that 13x? What do we think we do, Kyle? Subtract it. Minus 13x. Do I do it on one side? Exactly. What we do to one side? We do to the other. Minus 13x. Are negative 12 and negative 13x like terms? No. We can't combine them. I like to keep my variables in the front. So what I'm left with now is I'm left with negative 11y is equal to negative 13x minus 12. Sounds good, right? Now, what is our last step? What do we have to get rid of, Sean? The negative 11. And since it's being multiplied times the y, what do I have to do? If it's being multiplied by that y, what do I have to do, Isis? We do not add. Oh, we do isolate, but yes. How do I isolate it, Isis? If it's being multiplied, how do I isolate it? Kyle, what do we do? Sean, what do we side. So we're going to divide each side by what? What are we dividing by, Tyson? Negative 11. We are going to divide each part of those numbers by negative 11. There's supposed to be a negative there. Negative 11. Negative 11 divided by negative 11 goes away. We are left with y equals negative 13 divided by negative 11. A negative divided by a negative is a positive. So it just becomes 11, or it just becomes 13 over 11x. And then negative 12 divided by negative 11. A negative divided by a negative is a positive. So it becomes plus 12 over 11. Once again, we could write those as mixed numbers, but we don't necessarily want to. And I'm going to show you one more thing. We have this, 2/3 x, and I have this, 2x over 3. Are these the same thing, or are these different things? What do we think? Are these the same things, or are these different things? Kyle, what do you think? Kyle thinks they're different. Does anyone think they're the same? Bridget thinks they're the same. So we're going to test this, okay? I'm going to tell you that x is equal to 6. And I want you to plug that in to both of those x values and solve. Remember, here it's being multiplied. Here it's being multiplied, right? So figure it out. So for one, we're doing 2/3 times 6. And the other one, we're doing 2 times 6 divided by 3. So 2/3 times 6 and 2 times 6 divided by 3. I want you guys to tell me if these end up having the same answer or different answers. Tyson, what did you find out? That they're the same. They are. Bridget was right. They are the same. Let's watch. When we plug in for x, let's plug in that 6, right? Here, I've got times 6 for both of them. So, if I'm multiplying a fraction times a whole number, what do I have to do to that whole number? Tyson? Make it into a fraction. So I put it over 1. And then I across multiply. So what is 6 times 2, Sean?
6 times 2?
Yeah. 12. And then what is 3 times 1? What's 3 times 1?
3 times 4? Wait, 1. Oh, wait.
It is 3. Yeah. On this side, 2 times 6 is equal to 12, and we're still over 3. Already here, we know that they're the same. We could have even done this. We could have cross-canceled stuff. 6 and 3. If I cross-canceled the 6 and the 3, what does the 3 become, Tyson? And Sean, what does the 6 become? A 2. Because what happens when we simplify this? What is 12 divided by 3? Who can tell me 12 divided by 3? Melanie. Bridget is correct. It is 4. So for both of them, they are the same. If you see it written like this, or if you see it written like this, it is the same. What about if I had it written like this? Is that the same? No. The variable can either be next to it or on the top, but it cannot be on the bottom. It will not be the same, okay? Now, I want you guys to try this one on your own. 9x minus 7y equals negative 7. Try that one on your own. So, Sean, walk me through what you did.
First, I subtract 9. Subtract 9.
Just subtracted 9? And 9x.
Oh, yeah.
So you subtracted 9x to both sides. Excellent. So that 9x goes away. We're left with negative 7y is equal to what?
What? Oh, sorry.
Negative 7y is equal to what?
Can't.
Yeah, we can't combine it, so what does it turn into? It just becomes minus 9x minus 7.
Yeah.
Perfect. Marcus, what's the next step? What does he have to do? We have to divide. So what are we dividing by? What are we dividing by, Tyson? Perfect. -7, because we want to get that y by itself. -7 divided by -7, that goes away. We're dividing this whole side by -7. I draw that big line, means divide, -7. What I end up getting is, I get y equals 9x over 7 plus 1. Looks good, right?
Yeah.
Tyson, you have a question?
I did the same thing, but I
Forgot the variable. Exactly. That's where we have the problems. We have to remember the variable. So now let's look at this one. This one doesn't give us an equation. This one says this. Our line goes through these points and it has a slope of that. So let's follow our formula. We know it's going to be y equals mx plus b. What are the pieces of information that we know? Give me one piece of information that we know. So this is the information we know. We know what the slope is. So Romario, which letter means slope? M. So we plug that in there. So now we've got, instead of just an M, we know it's a 7. What about this up here, this ordered pair? What does that tell us? What does our ordered pair tell us, Marcus? So what does an ordered pair look like originally? It is what, comma, what? X, comma, y. So then what's our x value then? Our x value then, Marcus, is 1. And then what's our y value then, Sean?
2.
It is 2. Excellent. So now we have all three of those pieces of information. So we're trying to solve for the b. Now, because it was a variable, because it was 7x, we know it's 7 times x, so it's 7 times 1. So if we solved this, we now have it like this. We have 2 equals 7. 7 times 1 is just 7, plus b. We need to solve for that b. How do I solve for a variable? How do I solve for a variable? What do I have to do to it? Sean?
You have to subtract.
Yes, I have to isolate the variable. And how do I do that, Sean? You're just saying?
You subtract 7.
Excellent. So I subtract 7 on each side. 7 minus 7 goes away. So I'm left with b equals. And who can tell me what 2 minus 7 is, Marcus?
5.
Is it?
It's
It's
a -5.
a -5. Excellent. So our b would be a -5. So then we would write the equation as y equals 7x plus 5. Y equals 7x plus 5. We're going to do one more together. Here. Perfect. So I want to plug this in. We already know our formula is y equals mx plus b. So I'm going to call on you. Victoria, what is our y value? Yes, so we know our y is -1. Excellent. What is our x value? Perfect. Perfect, Alyssa. It is 3, so we know we've got equals something times 3. Do we know what our b is? No, that's what we're trying to find, plus b. And then what is our slope, Sean? It is -1. Excellent. So now if we did this, we now have -1. What's -1 times 3? -1 times 3, Romario?
-1 times 3.
Thank you, Marcus. It is -3 plus b. So now we know -1 equals -3 plus b. -1 equals -3 plus b. I have to isolate that variable. So how do I isolate that variable, Isis? I want it to get down to a b equals. How do I isolate it? I don't divide it. What do I do, Marcus?
Subtract 3 on both sides.
So I'm not subtracting 3, but what am I doing?
Adding 3.
Adding 3 because it's already a -3. We can't forget about that operation. So I add 3 on both sides. Negative 3 plus 3 goes away. What is 1 plus, or negative 1 plus 3, Vito? Negative 1 plus 3.
2.
Perfect, it's 2. So our b equals 2. What we know we are left with, our equation is going to look like this. Y equals negative x plus 2. Because negative 1 is the same as just negative. We don't need to put the 1 there. The last fact that I want to teach you is when we're dealing with parallel slopes. So parallel slopes. If I had a slope of negative 3/4, the parallel slope is going to be the opposite inverse. So what's opposite of a negative, Marcus? Positive. And what's the inverse? What's the reciprocal of 3/4? What's the reciprocal of 3/4 for Mario? Perfect. 4/3. So in this case, the parallel slope, if this was our original slope, the slope that is parallel to that is 4/3. Who knows what parallel looks like? If that line is 1, what is the parallel? Tyson?
It's like going in the same direction.
No. Oh yeah, I'm actually teaching you completely wrong.
Oh, yeah.
I'm actually teaching you completely wrong. I'm thinking of the wrong thing. So parallel slopes are actually the exact same. Parallel slopes, thank you Tyson for correcting me, are the same. But in a different circumstance, perpendicular slopes are lines that form 90-degree angles. Those are the slopes that are opposite inverse. So if this one was negative 3/4, then that slope would be positive 4/3. But parallel lines, because they run the exact same as one another, they have the same slope. Because they run the exact same as one another, they have the exact same slope. So what we did with that earlier equation, we had and we solved and we got y equals negative x plus 2. The reason that we're solving for this, the reason that it's so important, is because I might give you a t-chart. I might give you a t-chart and ask you to fill it out. In fact, that's what I'm going to do for this problem. I'm going to give you a t-chart and you're going to fill it out for me. When x is going to be 1, 2, 5, 0, and then when y is going to be 7. So I want you guys to fill out that t-chart for me. The way that you fill it out is by plugging in the value. You plug in the value. So for the first one, I'd plug in 1 for x. The next one, I'd plug in 2 for x. Then I'd plug in 5 for x. Then I'd plug in 0 for x. And then I'd plug in 7 to y. So try to do that t-chart. So if we plug in 1 for x, I get negative 1. What's negative 1 plus 2? What's negative 1 plus 2? What is it, Marcus?
Positive. No.
Positive 1. Excellent. What about the next one? If I plug in 2 for x, I get negative 2. What's negative 2 plus 2? Sean.
Negative 2 plus 2 is
What is it, Romario? 0. What if I plug in 5? I get negative 5 plus 2. What is negative 5 plus 2, Romario? Yeah, negative 3. What if I plugged in 0? What is negative 0 plus 2? Negative 0 is just 0. What is it, Tyson? 2. And then lastly, if I plugged in 7 for y. Now I've got 7 equals negative x plus 2. We've got to work a little harder. We got to isolate that variable. So I'm going to subtract 2 from each side. I get 5 equals negative x. So what is x going to equal then, Sean? If 5 equals negative x, then what is x going to be? So if I want it to just be x, I'm going to divide by a negative. I have to divide each side by a negative. What's a negative divided by a negative?
positive.
What's a positive divided by a negative?
Negative.
Thank you, Vito. It is negative. So our answer would be negative 5. Do we see this? Let's look at this pattern here. Here, I went up 1, and here I went down 1. Here, I went up 3. Here, I went down 3. Here, I went down 5. Here, I went down 5. Here again, I went down, I went down 5, and I went up 5. And here I went down 5, and I went up 5. Notice that the ratio tables, it's the same. It's a ratio table. Each one has to follow the same pattern, right? Each has to follow the same pattern. If I'm going up 1 and then going down 1, the negative has to follow the same on the other side. If I had this one, let's say I had 1, 2, 3, 4, and I had 8, 9, 10, 11. What would my formula be here? What would my equation be? Who can tell me what my equation would be? Tyson.
Like plus 1.
In this case, y equals x plus what?
Plus 1?
Is it x plus 1? Remember, this is y is equal to x plus what? How do I get from this to this with addition? Plus 7. And does that work for all of them? Yeah, that works for all of them. And notice, what if my x was 0? Here, if my x was 0, it would be 7, right? Because I'm going down, 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 down. And that's the y-intercept. That's when x is 0. So that's how we use our t-charts to solve. Excellent work. Gonna give a shout out to Romario, Isis, Victoria Wooten, Tyson, Sean, Marcus, Victoria, Bridget, Alessa, Melanie, and Vito. Thank you guys all for coming to my homework help.